Welcome, everybody. My name is Micah Silverman. I run the DevSecOn chapter of Virginia. And tonight I am very excited to have Jonathan with us from Modern. I hope I pronounced that right.
You did?
Reasonable, close enough. Okay, excellent. Just a little bit of housekeeping here. Feel free to drop messages in the chat throughout. I will make sure to relay them to Jonathan. He's perfectly open to breaking and makes it more fun when people interact and drop in some messages, questions, comments, whatever you have along the way. For the choice ones, I'll make sure to throw them up on the screen. And I'm very excited for our little dive into OpenRewrite tonight. And in case you don't know him, I'm looking off to my notes here. I just want to introduce Jonathan. He's an engineer by background. He founded the Micrometer project of Spring. Is that right?
That's right.
Yeah, and as a co-founder of Modern, which is all about automated refactoring, part of what we're going to be talking about tonight. And Jonathan's got a big program coming up in DevNexus, which is one of my favorite conferences of the year. He's going to be doing a 7-hour workshop on OpenRewrite recipe development. And then he's going to be doing another talk on mixing Gen AI with RScale rules. And I think in both of those sessions, you have colleagues that are going to present with you. Is that right?
That's right. Yeah. So for the workshop, during co-founder Olga Kunzic will be with me, and for the Gen AI session, it'll be Justine Gehring from the Milo Institute up in Montreal. Also works for Modern now.
All right, very good, and I'm particularly excited. We don't, we have speakers from every walk of life, every type of framework and tooling and language, but I'm very excited tonight that there's kind of a Java lens here because Java is my main squeeze, and hopefully it is for others as well. So with that, I'm going to remove myself from the stream. I'm going to add in your screen share and take it away, Jonathan.
All right. Yeah. Thank you for inviting me here. Maybe we'll start without the screen share initially, and I'll tell you when to that works. So just a little bit of introduction and background again, Jonathan, and this concept of automated refactoring of source code started for me back at Netflix back in around 2016. I was working on engineering tools, a central team there at Netflix, and you may know they famously had this freedom and responsibility culture, which meant really, with respect to an engineering tools person, we couldn't impose any constraints on what product engineers did. So think about this in terms of migrations that we were trying to get folks to go through in their source code, fixing vulnerabilities in code, using better patterns or practices or code quality type things. Typically, this is something we'd insert into the software delivery lifecycle, right? And CI/CD, where we run some sort of scanner, and if something doesn't meet standards, we break the build. But that was actually anti-cultural there at that time. We couldn't break the build; it would interrupt. It would take choice away from that product engineer. So, nevertheless, we invested quite a bit in scanning technology, trying to produce reports, making them really lively and informative for our product engineers. And it seemed like no matter what we did, it yielded approximately zero action. I think that's what we learned there. So as we go around talking to developers from those teams, I'd ask that simple question: what can I do to make you move forward with me on something? I'm trying to move you from Java 7 to 8. I'm trying to move you off of an old logging framework, whatever it may be. And the kind of consistent answer was, do it for me. Otherwise I've got other things to do, right? And I think there's a lot of truth to that. Developers had just all this stuff on their plate. They've got business requirements, most importantly, and then they've got a variety of central teams asking them to make changes all the time. So they're just running out of time in the day to do those kinds of things. So if you hear that line enough times, do it for me, you start to think, where are there opportunities for automation on these things? And so we started small. I started a project called Gradle Lint, which was just revving dependency versions in Gradle files, it seemed like a tough challenge because Gradle obviously is just arbitrary Groovy code on some level, but managed to make that work well enough. And then we started thinking, well, if we can do this in Groovy files and for the build, why not do it in main source code? So, we started. So that's where this project, OpenRewrite, which we'll talk about today, originated. Is the idea of being able to make source-to-source transformation to accomplish some change in the code that we want to see. I think we can go to screen share now, and this is going to get, as we kind of go through things. So this is OpenRewrite today. It's out here on GitHub. There's a whole organization called OpenRewrite here. Rewrite is the sort of core project, and what it really is a set of language parsers. So we're turning source code into a representation that we call the lossless semantic tree, or LST. So you'll hear this word LST a bunch of times from this point. To kind of put a visual, picture to this, what is an LST? We've kind of got the text of the code, right? So you think of this method M, which has got an if statement and a while loop. And if you remember from your compilers class, the first thing the compiler does with that text is it tokenizes it and turns it into an abstract syntax tree. That syntax tree, if you think of these blue vertices in the middle photo there, they're going to represent the different syntax elements. So, the method M is going to be a node. The letter M, the identifier of that method, is a node that's connected to that, and so on and so forth. This syntax tree helps us to break the code apart into these like structural things, right? So already with an AST, if I wanted to find all methods named M, I could do so without a really complicated regular expression or something like that, right? I could navigate to elements of type method, look at their name identifiers, and see if it's called M. But what's missing from the abstract syntax tree, and this is a lot of tooling is built on top of this abstract syntax tree. What's missing is the information that the compiler puts on the AST next, which is the type information. So the compiler is going through and doing this solving exercise, right? Which is when I see the method P here, I'm calling P, where is P defined? What is its receiver type? Where did that come from? There could be methods called P on many different types. So it's, maybe in this case, there's a P variable somewhere with an import statement, or maybe the method P is actually not defined somewhere in the source code itself. It's coming from, a binary dependency relationship or something like that. At any rate, the compiler is responsible for determining that. So it does this phase called type attribution, where it goes and basically decorates that AST with information about all the types. If you take those two together, so the syntax nodes, and you bolt all the type information on top of it, you're getting close to the lossless semantic tree. The one thing that we're missing then is the original white space and comments and all that other stuff from the original text of the source code, because the compiler doesn't care about that stuff, right? It's going to throw that stuff away really early. To build this lossless semantic tree, OpenRewrite will go and grab all of that original white space and comments and all that stuff and stick it back on the tree adjacent to the syntax nodes. So the combination of all these things together, the white space of the original code, the syntax, plus everything the compiler knows about the types in use, together is the lossless semantic tree. So why do we go to such extreme length here to create that data structure? It's only when you really have all of this information that you can achieve transformations on source code that have two characteristics. One, that there are no false positives, or that the change is provably correct. If I want to go change methods of type P on a certain receiver, I have to be able to prove, even if it's not visible in the source code itself, that that method P has that receiver type. And then the second characteristic that's really important is if I'm going to make a change in code, the change should look stylistically consistent in the context of the repository that I'm suggesting the change in. Now, as we know, we all have our preferred code styles, but there's the tabs versus spaces debate. There's the brace on the new line or on same line. There's all sorts of different styles. One thing we do know, I don't know which of these things is right in every case. One thing I do know is that developers care very much about the style of their code and keeping that. So it's really important that these changes get massaged to look idiomatically consistent. This has been a lot of words, so let's see like a specific example, I think, of a change that was prepared by an OpenRewrite recipe. Now recipes are programs that perform these transformations, and we'll get into more about this in a moment. But first, let's just see a kind of change, because I want you to see, some of the nuance to keeping style. So there was this change not too long.
Jonathan, I hate to interject, but can I humbly request that you make it a tad bigger, the text for your browser? Yeah, absolutely. Great, thank you.
Yeah, so there was this change, JUnit 4 to 5 that some of us are still going through. JUnit authors made a generational change to the framework, and they made changes that can seem kind of sometimes silly on the surface, like they changed the type org JUnit before to a different package and different name, org JUnit Jupyter API before each. But in effect, what this means is I've got to go back through every unit test that I ever wrote and make these kinds of changes over and over and over and over and over again. So before each, like there used to be this run with Spring Runner that doesn't exist anymore. So I have to strike every one of these. Some of the changes are much more structural. I used to be able to define an exception on this test annotation, but now I have to use an assert throws block where the exception is down here, and I shove the rest of the method body into a lambda. So these are the kinds of changes that I have to do over and over again. So when it comes to style preserving, think about this method. This method uses tabs for its white space. So when I kind of push the rest of this into a lambda, I'm going to use tabs. I'm looking at the import ordering format of this project. How do they block up imports? Do they use wildcard imports? How many types in a package to use a wildcard import? All of these things are derived from the existing code, so that the recipe is automatically able to make these changes that look right in the context of this repo. But so for this change, just this one thing, this JUnit 4 to 5, I would just have to go through as a developer and do this over and over and over again, right? This kind of work is not fun, right? I used to joke that this is what baseball is great for. I've been a Cardinals fan for my entire life, but like it only occupies half of my attention, and this kind of coding work only occupies half of my attention. So this is what I would do, this kind of thing. Now this is one repo, right? This is just one repository that I got to update. Imagine, I had 1,000 repositories to update. And the thing I like about this example, this JUnit 4 to 5 thing, is it's just unit tests, right? It's not even main source code that's affecting my business application. But recently, I think just this last month, Spring Boot 2 was end of life. And to migrate to Spring Boot 3, I have to move from JUnit 4 to 5. Now, knowing that Spring Boot 2 is end of life, how long do you suppose it's going to be before the next zero-day security vulnerability is discovered in Spring Boot 2, and my only remediation path is going to be able to migrate to Spring Boot 3? And now I've got to go do this on every single one of the unit tests I ever wrote. That's why I think as really as a software industry as a whole, we really struggle, to like keep things up to date and keep things secure. because this kind of mechanical change is just kind of overwhelming us. It's almost as if, and I like to say that software and production, right? Software development has been industrialized. Our IDEs write code very quickly. Now we've got AI assistants, Copilot, and its ilk helping generate new code quickly. But the maintenance of it is like this really kind of like, backyard process still, right? Where we're just kind of hand jamming all these changes out. So we need a change, right? And that's really what I think we saw with OpenRewrite 8 years ago, and it's more true today than ever. So I mentioned that rewrite really is a program, and I'm like Mike had mentioned, I'm an engineer, so I like to get straight into code. I'd like to give you a taste or show you really quickly what a recipe looks like. And if we have a little bit of time later, we'll develop a security specific recipe. Just for the sake of time, I'm going to write one that's even simpler, just to give you kind of a sense of what the parameters here really are. But to go over to an IDE really quickly, I'm going to write a quick recipe called change literal to 42, and just notice that this is just a class, just a Java. I'm writing in Java here, and it's just a regular old class that extends OpenRewrite recipe. Because so you got to love Copilot for these kinds of things. The generation of description text and things like that. It's a recipe uses the visitor pattern. You can think of the visitor pattern as an event-driven system that's going to intercept different types of tree elements and allow you to kind of respond to each one. So I could say visit literal here, and no matter how complex this tree is or how many different kind of types of things there are, what I'm going to do is just be interested in the literals in this case. So I could say, if literal.give value, is an integer, then I want to change it to 42. I think, we'll see if that works. I think we should check the type on this too. To say the type is, this will be good enough, I think. So let's go over here to write just a quick unit test for this. I could say change literal to 42 test implements rewrite test. And so we have a testing harness called rewrite test, where I can basically define different different example pieces of code here. So, and in this unit test harness, if I add a language annotation here, it's inside of a text block, but the IDE is going to autocomplete or syntax highlight the contents of this anyway for me. If I say int I equals 1 here, then so this is some before text that I'm starting with. I could copy this and say that I'm asserting that the after text should be 42 after this recipe is done. And on this test, I can set, I'm going to say this is the recipe that's under test right now. And if I've changed the value itself to 42, I need to change the text of the value, the way it's defined, because this could be written as 42 or it could be written in hex or these kinds of things. I need to kind of specify which. I can say, let's do this. And note there that, 1 changed to 42, right? So that is the kind of, that is the goal. I've just intercepted literal. I've said if it's an, it's an integer, and regardless, I've changed it to 42. right? That's an example there of, of a rewrite recipe making the change. So some things to note here. I mean, these recipes, because they're programs, they can really be, you could kind of do anything you imagine with it, right? We've seen folks inside of these recipes make calls to external systems to, fetch data from somewhere else, and then as the recipe is executing over a large body of code, it's acting on that. So one good example of that, in major financial institution is taking, they use LaunchDarkly, the feature flagging system. They make an API call. So imagine just making an HTTP call here to LaunchDarkly and asking LaunchDarkly to list me the unused feature flags, the ones that aren't receiving traffic right now. And then as they're kind of visiting through the code, they're looking for these unused feature flags, the actual code that uses it, and just ripping out the code. At the end of the recipe, they make a delete request to LaunchDarkly to just purge the feature flag from that system. So it's really interesting because recipes aren't a query language or like that kind of thing, that you can stitch these things together with other systems to add really rich information. If you're interested actually in that recipe, the one that finds feature flags anyway, there is a rewrite LaunchDarkly out there now, and it's got this find feature flag recipe, and you'll see it's got a lot of sophistication. Recipes themselves can have options, so that allows you to parameterize them with different things like what flag type and key you're looking for, and then use that somewhere in the recipe to look for things. So once I have a recipe like that, again, recipe's a program. It gets kind of bundled up. I want to be able to run that potentially at scale on thousands of repositories or hundreds of repositories. So one way to do, you can kind of do this one repository at a time through OpenRewrite build plugins. Like there's a Maven plugin, there's a Gradle plugin. You can apply the plugin, run a recipe on a particular repository, and get some value out of that. For Modern, we provide some tooling in a couple different ways that allows you to run a recipe on a lot of repositories. And I think this is the direction that you're going to see a lot of tooling go. And so it's interesting to kind of show what that looks like. So here in this repository, in this directory, I've cloned in this folder called working set. I've cloned 3 repositories. So there's 3 Git repositories that are on disk right here. And I can run this like mod list, this working set. And the goal here is just to identify repository roots. Like there's 3 Git repositories identified somewhere recursively in this directory structure. But now I can say mod run, common static analysis. This common static analysis recipe I'll show you in a moment, but it's basically a bunch of like SonarQube style rules that we've rewritten as OpenRewrite recipes. Because why get nagged about something by a scanner like that when you can just fix the thing, right? So a recipe that can fix something can naturally find it. Here I'm running it over all 3 repos, and the recipe has prepared a patch file with the changes that are being suggested. So I can kind of look through all of these. And once it's done, it's saying I could then take all these patch files and apply them to the code base on disk, and then follow that up with commits to those repositories to just fix these issues and be done with it. There is another interesting element to this, which is that recipes, in addition to making changes to code, can also emit what we call data tables. And data tables are just like columns and rows of data that according to a schema that the recipe defines. And so you'll see, this recipe added 55 rows, this one added 2, this one added 3. If I open up this resultant XML file, you're going to see, this is the repository, this is the file that changed, this is the recipe that made the change, this was the estimated time savings in seconds, and I can kind of get a summary of what this recipe ran. But there's a number of different open source, OpenRewrite recipes that write data tables for all sorts of different kinds of things. The find methods data table or recipe writes rows out where it shows, like, if I'm looking for all usages of JavaLang string, any method name, I'm going to say this source file had this call using JavaLang string. This one had this one. This one had this one. And you can kind of list in one table all of the occurrences of this kind of thing. So those data tables are very, I think, interesting to try to wrap your mind around how prevalent something is really before you get started on making a change for it. So let's think about, like, how, like, so there's, you saw that CLI that's operating on multiple repositories on disk. Here at app.modern.io, this is a version, or we run this in a single tenant fashion, but app.modern.io is a platform we're running for about 300 million lines of open source code. We deploy recipes to this, and we parse that 300 million lines of code into LSTs and make them available here to run recipes on. So take that common static analysis issues recipe we were just looking at. Note that this is a composite recipe that contains a lot of different individual recipes as steps to run. And I could select some code base, like maybe I'll just take the OpenRewrite code base here and dry run this recipe on all 39 repositories. So I'm able to look at the changes fairly quickly. What's being suggested to me. I can't immediately tell what this is. So I could say, why did this change? And it says, hey, we're trying to avoid nulls here. That's why we're doing that. Here it's saying these parentheses are unnecessary. So ultimately what I can do as a developer is just take this, since I'm an author on OpenRewrite, I can just commit directly, but I could do a pull request instead. I'm just going to commit this one directly and clean this code base up. And so this is going to take that diff that was prepared by OpenRewrite, and you'll notice that when I look at the repository, that commit has now been made upstream in the repository. I'm the author of it because I'm the one that decided to do it. Modern was just helping, but that change now is made. And imagine now, like, when I go back here to that recent recipe run, I had how many repositories that had code quality issues? What I really could do is just commit all, right? And now I'm committing to 22 repositories simultaneously to just wipe out this issue. That's really, I think, what we're after. So code quality issues are one thing. When I think about something like Spring Boot, migrating to Spring Boot is it's like there's a lot of steps in it that's hard for me to know, what it is that I'm supposed to do. If I look at this recipe, migrate to Spring Boot 3.2, I have to update dependencies. I have to migrate to Spring Security. I have to enable virtual threads, apparently. I have to change types like this that have moved from one place to another. To migrate to Spring Boot 3.2, I first have to move to 3.1, which means I have to go to 3.0, which means I have to go to 2.7, which means I have to go to 2.6, 2.5, 2.4. That has that JUnit 4.5 thing, which has a Makito 1.3 thing, which has so these, just as a developer to try to understand that really all of these changes I need to make in order to get there, just could be, that could take a lot of time. So this recipe is one that I can run and, complete this task, across a large body of code. Let's run this on like something else like Netflix and Spring or something like that. So this is 118 repositories here. And so loading means I'm going to try to I'm actually loading that recipe up on a specific node over there.
While this is running,
Yeah,
Jonathan,
yeah,
I dropped a question, and I'm curious to know if the recipe handles some of the Spring security
it
changes with the
does.
Spring Boot, like the embedded functional calls and stuff like that.
Right, right. Yeah, I mean that's you saw that Spring Boot 3.2. There was that individual recipe on migrating to Spring Security 6.2, which may have other 6.1. So they'll have these individual steps in them. When I think about something like this, like 3.2, it's an important thing. Like philosophically, I believe that when framework authors like the Spring team are making breaking changes, they owe us recipes to fix us as downstream consumers. That's why we are very committed to OpenRewrite being forever and all the recipes in Apache licensed ecosystem, because I believe that you have to have framework authors up and down the language stack providing recipes as they make breaking changes. You saw that to migrate to Spring, I have to migrate to JUnit 5. To migrate to JUnit 5, I had to migrate my key to 1 to 3. So it's, really everybody needs to pull their weight on this. And we do see good participation from, the Spring team has 2 engineers that work full-time writing recipes. Red Hat has engineers writing recipes. Oracle has engineers writing recipes. You may have seen AWS announced last week at reInvent that they're writing recipes now, and that AWS itself or Amazon itself just upgraded 1,000 of its applications using those recipes in 2 days. So this really is like a sort of generational shift, I think, in how we think about modernization. It should not be a manual activity, but one that's we're all contributing to at the the sort of like open source and third party ecosystem on which we all build, and we're able to do that and move together quickly. So that. I think that's kind of the nature of that. I'll pause for a moment here and just see if there's any other questions. And I'm not sure how much time we have, but I'm happy to get into developing a more security oriented recipe as well here.
Oh, I'm muted. We still got about a solid 27 minutes or so left, but yeah, I'd love to hear some other questions too.
Yeah, let's get into it.
We
While we're
got
doing that,
from Anbu here, we got AWS's big announcement.
I posted the link. I'm running one here while other folks think of things that they may want to know. There's this interesting recipe: find sensitive API endpoints. These aren't really sensitive pieces of data, obviously, but like let's suppose they are. What I find interesting about this one is, it's going to really show, I think, the power of type attribution. So if you remember, type attribution was these little yellow things, the things that compiler is inferring about these types as it goes through the syntax tree and solves for them. We'll kind of wait for this one to be done. This one I'm going to cancel and make room.
While it's going, we have a question there from Anbu.
Yeah, go right ahead.
What's the best practice to integrate OpenRewrite with CI/CS? Like whenever any library release happens, it automatically makes changes.
Yeah, absolutely. I've seen a couple things here. So first of all, like the for CI/CD, like I do think it can be useful as a central team to like provide recipes to migrate the things you're interested in, and introduce those into your builds, to help developers move. I think the best way to start is to be very servant oriented, to recognize that not everybody is ready to move at the same time. And so, add that step that runs a recipe with one of the build tool plugins, and it kind of tells them, hey, there's work here to be done. And by the way, if you just run rewrite run on this particular repository, it's going to be fixed. So I'm not asking you to do a lot of work here. I'm just asking you at a moment where it's convenient for you to do it. And so I used to do this at Netflix. We would issue PRs. but we would also run things in the build, things that were important to us. And we would track and watch as a central team, how far along we were in getting an issue closed. And sometimes when the issue would be closed all the way, we could then introduce into a CI step a gate. At that point, say, you know what, we've gotten rid of this thing. Maybe it's a security issue. Maybe it's a quality thing. We've completely gotten rid of it in our code base. Now I'm slamming the door shut on this issue. I don't want to see it come back again. And if somebody ever makes a commit that recipe detects, a change for, it's not super harmful to them, because I'm introducing that new code. It has a problem, but I'm also providing you the easy way to fix it immediately. So that's the way I tend to think about this. Switching gears, I was running this sensitive API endpoints thing in the background here. This recipe was designed to look for HTTP endpoints that had, quote unquote PII exposed. And what's super interesting here is, you see this method which returns a vets object. Well, vets in turn has a vet list, which in turn has a person, which has this first name, which we declared PII in this case on it. So, this kind of shows, I think, the power of the LST, the lossless semantic tree. We don't just see the text of the code. The text of the code just says vets. It doesn't say anything about what's inside of vets. But because we have all that type attribution information all the way down, we can actually navigate down that structure and see, things about the code that are not apparent from its textual representation. One of the other really interesting things here is to look for deprecated methods. Like I could look for deprecated methods. There's a method pattern here. I'm looking for every sub package of Spring, every type, every method, no matter how many arguments. And let's say I look for deprecated usages of Spring in Spring. So this 80 repositories of Spring. I kind of love this one because it kind of shows you how hard it really is to keep up with change, right? Here in Spring Cloud Stream Binder Kafka, this consumer properties that set authorization exception retry interval is deprecated. And yet they still use it. String in utils.isEmpty is deprecated in Spring, and yet it's still there in the Spring code base. So, these are, again, the fact that this is deprecated is not visible in the text of the code. But when we have that LST, we're able to look at the type attribution information and look up the method declaration, or maybe even, it's overriding in a method declaration in a super interface, and somewhere upstream there, it's deprecated. So it's really, powerful tool to go look for these things. So happy to take other questions here. I'll show one more thing here, and then we'll use, if none other, we'll hop over and we'll look at, a more security oriented use case real quick.
Thanks for indulging my security use case questions, but let's keep cooking. It looks great.
Yeah. So, I mean, it's, we talked about data tables earlier. I showed how we produced that Excel format. Here on Modern, we've kind of gone one step further, and we've taken that, ability to produce a data table and taken it and also allowed people to develop Jupyter notebooks that are dynamically injected with those data tables that then visualize that data in some way. I'm looking for one that's interesting here that's been running recently. Maybe this one, I don't know. Yeah, so like this is an interesting visualization someone wrote to look at all the Jackson usages of Jackson across some organization, some set of repositories. And you see a violin chart here, Jackson 211, 211.3, 13, 14, 15. And, the width of the violin plot at any given time indicates its frequency. So you can kind of see sometimes we're falling behind, sometimes we're kind of up on the current thing. And you see the distribution of this across a large set of repositories. So these kind of visualizations and data tables, so we think of OpenRewrite as kind of like a general purpose data warehouse for code where you may be trying to answer questions and determine the scope of impact, and then where you see opportunities, making the refactoring change to do so. So if I just think about OAuth top 10, we're continuing to write recipes in this area as well. Going back to this one, OAuth top 10, just we've broken this down into each of its kind of pieces here, and then of course these are all going to be recipes that have sub recipes underneath them. But as we identify issues, let's go write recipes as security researchers that don't just disclose a problem, but help developers downstream fix them. So with that, I'd say let's look at one that's kind of, or we can start to look at one. We probably won't have time to completely finish it, but I'd written a unit test right before we came in here about looking for secure cookies as an example I saw before I came in here. So if I defined a cookie and set a value on it, and I either didn't set secure true or I deliberately set it to false, how would I detect this scenario, knowing that there can be, any number of calls between these two things. So it could be kind of this intermediate call between these. And how would I detect this scenario of a cookie that doesn't have a secure attribute set on it? So, going over to, again, a recipe, I have this display name, I have this description, I have a Java ISO visitor. There's some other patterns I can use, like I'm looking for this Java servlet HTTP cookie. In this case, I'm wanting to look for constructors. And I'm just first looking for this piece right here, right? So here I can say visit new class, if new class new cookie matches new class. The first thing I can do, and one of the things that is often easiest when you're developing these, is just to say imported the wrong type up here. New class, sorry. So if I were to take this, we can render a search result as just a little comment here that indicates that I found something. I found that new cookie reference. So I have this recipe cookie is secure here. I specified that it needs this dependency because that's where that Java servlet HTTP cookie is coming from. And if I run this, note that, yeah, I've been able to identify this new cookie as, the thing I was looking for. So that's an interesting place to start. But now the thing is more interesting. I want to know if then the variable cookie was ever used to either it didn't have the secure attribute set to true, or it explicitly had it set to false. And so here I can use a data flow mechanism that's built into Rewrite as well. So I'm going to start the data flow at the current cursor. The cursor represents just the stack of AST elements starting at this new class and going all the way back up to the top. And I'm going to look for syncs. And for source, I'm just going to say, yeah, it's always a source. If I could say, this is the as I'm testing each of these things below here, we're looking for usages of this variable that comes from this source. So I'm going to look for, let's just see what we see here. If I look for the object that I'm testing to see whether it's a sync, and I'll say, is some, and we'll assign this to is secure, and not use it for now, but run this here again. Whoops. What happened here? Recipe made no changes. Yeah, of course it didn't. Let's see. Oh, my breakpoint had disappeared. Yeah, so the first value it's going to visit is, well, the cookie, it's the new instantiation itself, then this identifier, and that's it. So what it kind of visited was here and then here, right? But this is the identifier, which is the receiver of a method. And so if I think about the structure of this AST, it's like a method that contains, different parts, and an identifier for the name, or for the receiver, the variable that's an identifier for the name, which is set secure. You're going to have some arguments. There's different things that are on that LST type. So here, this cursor represented in this case just that cookie right here. So if I say, get parent tree cursor dot get value and run this one more time, I hope to see the containing, tree, the parent, the one that's above it. And here you see that, the containing thing of new cookie is that whole variable assignment. The containing thing of this, identifier is that whole method invocation. So now what we really want to test for is that there is a method invocation where set secure is not set to true. So I could say set secure, that's kind of the method matcher for that set secure method using that pattern we described earlier. And so I can say if value is an instance of j.method invocation and set secure dot matches value, we're a bit closer. I can say, value dot get arguments, the first argument here. And then we say if arg is an instance of j.literal, and not really what I want here. I would say boolean dot true that equals. Nice try, Copilot. I'll say, that it's true, otherwise it's false, right? And of course this can be simplified. So yeah, I'm looking to see, is the sync a set secure method, and is it true, right? Is it set to true? In that case, it would be secure. So if not is secure, then we want to say search result.found new class. So for this one, I'm going to detect this as an insecure cookie right here, in theory. Yep, that looks good. Now let's test the negative case, right? And this one, if it's true, I should not put a marker on this one, right? Because it is secure. So that's true as well. And then the third thing is, what if there was no secure call at all? And unfortunately in JavaScript or in Java, cookies are insecure by default. So, I'm going to be looking for this case as well. And if I delete that, I do want to find this one, right? And notice that back over in the recipe, I said that I had to find some set secure method with true as the literal value. Otherwise, I consider it insecure. and that passes as well now. So now, yeah, so we've kind of addressed these 3 different scenarios so far in detecting this. Um, you know, I was pretty quick. We just got a fairly complex detection here in 10 minutes or something. From here, and this is how I usually write recipes like this. It's to add a search, and then I may even take the search then and run it over hundreds or thousands of repositories. I want to see whether this is even really a problem in my code base. And if it is, and if it's a sufficient enough problem, then I may go to the next step to turn this recipe into one that transforms and actually fixes the issue. So the fix, of course, would be when the set to false, set it to true. When there's nothing at all, add a set secure method that sets it to true. And I think we won't have time to quite build that today, but a lot of recipes out there in rewrite Java security that do very similar things, I think. So,
Hey, I have a quick question.
sure.
This reminds me of back at a startup I used to work at. We would write these test harnesses. We were developing an API and we had
Yeah.
SDKs in various languages, and we wanted kind of a uniform way to validate that the different SDKs were doing what they were supposed to. And I wonder if this isn't if this couldn't be used for that kind of use case to say, like, here's a recipe where you run this recipe against your code, and we'll give you some feedback on whether you're using this library correctly or in a secure way or insecure way or something like that.
Absolutely. I mean, that's and really that as you describe that problem, that really is still a detection. So the next level thing would be to make that recipe one that just fixes it. And
Mm.
so now you're not forcing that on the team, but when you give it that to them, then you're contextualizing the fix in their code base and you're saying like, here, this would make it better. Which is kind of the next step beyond just telling them there's a problem and specifically where it is, even as great as that is. I heard a developer one time tell me, I feel like I'm going around telling my kids to pick up their socks all the time. Like, like this level of exhaustion in the principal engineer, right? Oh, I'm getting new people all the time. We're getting new code bases from like acquisitions and stuff. And it's just this never ending pile. And so, we have our opinions, especially as we get more and more senior in our career. So take that knowledge that you have, turn those into recipes. And then you're basically teaching people on the fly, as they're doing something. One of the interesting ones, migrate to Java 17 is, if I ran this on a bunch of repos, the required things to go to Java 17 aren't that numerous. Notice that recipes don't just change Java code; they can change YAML code, they can Terraform, Groovy, Kotlin. We have JavaScript and Python parsers starting out now. We'll C# soon. We have COBOL, etc. But like, here I'm looking for one of these examples of a instance of check. Maybe we'll find one somewhere. Oh yeah, like this is an interesting example. This string.format is a pretty typical thing. Well, in Java 17, they introduced formatted method on the string itself, so you don't have to use the static form anymore. It's just a lot of developers just aren't going to know that that's even available. So you're not just seeing it in a blog post somewhere. You're seeing it contextualized to my code base, and I'm just going to go fix all these, right? So now as a developer working in this code base, I see this pattern and therefore I copy this pattern, monkey see, monkey do. It becomes, easier to move forward with that.
Kind of maybe a random question, but something that may help help me understand like the sophistication that it can get to. But could you write a recipe where it'll take string literals with lots of embedded new lines and tell you to convert that to a Java text block now that we have those available?
Yeah, that's exactly what this one does right
Oh,
here.
interesting.
Yeah, so you can see use text blocks. if you ask why did this change, I can kind of go to this recipe now, use text. Oh, okay, I see and I can even say, go to the source code of this recipe. This is how that was written. But yeah, I mean, this one's really subtle, right? Because there's not even a new line, but I can use these little things like this to, still put it in a text block without putting a new line in. It's just a little easier to read. That's configurable, so you can be more or less aggressive about it. But so this is another interesting thing a lot of people don't know about Java 17. You used to have to do this like if instance of, and then the first thing you do would be cast it. Well, now you can just assign a variable name in the instance of. And so we've just gone ahead and removed this, taken the variable name that you used and just put it up here. And, now all of those are cleaner, just better looking than they used to be. But, long is deprecated now. So that's going to break someday soon. You're supposed to use long.value of now. There's an is empty where they used to have only is present and you had to not it. So, I wish they had put that on there in the first place, but, it's so just a lot of things like that this isn't going to be a compilation problem, but, to keep our code bases kind of moving forward with the times, I'd prefer it to look this way.
Yeah, interesting. Yeah, and this reminds me of some there are just some style or best practices patterns like are you going to use the auto wired keyword on a private field, or are you going to have like constructor injection?
Yeah. I don't know if we've got that one deployed. I think we had a recipe on that at some point, but yeah, so yeah, I mean that's kind of what we've been after.
Yeah, this is exciting. I was kind of furiously messaging some of my colleagues on the side here. I contribute to the Java JSON Web Token project, JJWT, and we're about to go from a 0.x version to a 1.0, and there are definitely breaking changes, which is why we're going to 1.0. But having a recipe to help people migrate from the whatever 0. version they're on, that'll be really useful.
Absolutely. Yeah. And that's exactly what we want to help folks do. So we have that OpenRewrite Slack, which is visible at the top at docs.openrewrite.org. We have, the JUnit team in there, the Makito team, the Maven team has recently gone through and killed off an old string utils class that didn't want anymore. And so, actually that's I forgot to show that just really quickly. If you could flip over to the screen again here. These recipes, that we've been writing, they were using the visitor pattern, right? We see that as the base fundamental thing that we want rewrite to be built on. It's a program, so you can do anything you want inside of that visitor. But you can also start moving up the abstraction levels to make simple things easy to write. So this is an example. Actually, since we just mentioned Maven, let me go to that one. Where was it? This one. They wanted to kill off this old string utils. So now you can write some recipes like this. This you may or may not recognize as Google Refaster, style templating. Google had a refactoring technology many years ago that you could just kind of specify like before and after. And I'm looking for any expression of type string. I'm looking for any expression of type width. I'm looking for calls to string utils that abbreviate, and I want to turn it into this. So OpenRewrite supports this natively now. This will ultimately compile down to a visitor. So if I look at, the default string recipe here, capitalized recipe, notice I'm implementing this visitor. I'm visiting method invocation. I'm looking for a method matcher. I'm maybe removing imports. I'm putting preconditions around it. So it's just, making the easy things easier. I want to replace this abbreviate method. I want to replace the capitalize one. I want to replace this default string with objects.toString. And, so they quickly knocked out these recipes in, probably 30 minutes. And then now let's go execute this on the entire Maven organization on GitHub.
Very nice.
Yeah.
Well, cool. We're at the top of the hour. I got a few more minutes if there are any other questions.
Yeah.
Give people a moment to drop some questions in there. I like your analogy of telling kids to pick up their socks.
Yeah.
That's a good one.
Oh boy. Yeah. It's actually what got us going on this. Olga and I were working at Pivotal on Spinnaker, continuous delivery. We were going from business to business, large enterprises many times, talking about automated, canary analysis and things like that. People are like, oh, it's really cool. I want to do that. But like, oh man, talk to me in a year when I'm done moving Spring Boot 1 to 2, when I'm done, Bark for Shell, when I'm like, and so I was like, I think that's what was, let's maybe take this technology that we started at Netflix and start going more broader with that.
I'm also, it just occurred to me that for those of us that learn by example, as I do, I could imagine, I sifted through tutorials and did all kinds of, work to migrate from Spring Boot to Spring 2 to 3, right? And running the recipe and seeing the changes, the diff of what it was going to change, that would be a huge learning tool to get a leg up on what's changed and how things are going to be different going forward.
Yeah, absolutely. And, I feel like if we accomplish this as like a whole language ecosystem that like we really can move forward, it means we can just break faster, right? Like, I mean, the cost of a breaking change isn't as dramatic anymore. So we don't get stuck with, bad decisions or just, things change over time. It's not like we made a mistake. It's just things change over time. So it's,
yeah, and I can imagine it could really help with kind of that ambient anxiety. Like I'm somebody who's in the camp of like, the changes that JUnit 5 introduces are long overdue, but I'm also reluctant to switch everything over to JUnit 5 because I have this massive code base and this massive test base, and it's going to be like a headache, or that's the perception, right? So maybe it doesn't have to be as big a headache.
Yeah. I like that one in particular because, ultimately, if you're new to this, you feel like, I don't know if I trust this. I mean, he's saying it's accurate, but I don't know, like, at least it's unit tests, right? So at the end of that, either the code compiles and the test pass or not, but you're not going to, blow up your application in production on account of a bunch of unit tests. So
yeah, that's probably like a good place to start, right? Is
place to start. The
kind of a safe place to start.
Yeah.
Like, hey, I'm on JUnit 4, my tests run 100%. If I follow the path of OpenRewrite here, and my expectation is that everything will pass again, and if it doesn't, then I got to dig a little, but it's kind of a safe place to do that in. Yeah, very cool. Well, listen, we're a little over, but I really appreciate your time. This has been a great presentation, and my only distraction was kind of like firing off messages to people I work with, like, you got to check this out. So
that's right. Appreciate that.
It's been great. I'm looking forward to seeing you at DevNexus. We'll meet in IRL.
We can get much deeper into these recipes there. There's a lot to show, but
yeah, great. I'm glad you're gonna be doing this 7-hour workshop. I will dip into that.
Yeah.
Very good. All right, so in the next couple of days we should be posting the video from this, and with that we can wave goodbye to everybody.
Okay, goodbye.
I'll put up our little banner. Thanks again.
Okay, see you soon.